some more sampling with Excel. So it states right in the problem that they take these sugar stalks 50 at a time and measure them. So your sample size is 50. All right, so the first question is, if you sampled all of the plantation sugar canes 50 at a time, what would the sample mean be? It's the stated mean right up here. So it's going to be, remember, right there, if they're all of them, the mean's going to be 5.3, as stated in the problem. Made it pretty for you. Second question, what's the standard error? Okay, so standard error is the standard deviation divided by the square root of the sample size. Square root of 50 is 50. Square root 7.07. I'm going to call it 7.1. So that's going to be the standard deviation. I'm just going to use it as a regular calculator Excel. Standard deviation of 1.5 divided by 7.1. That's going to give us our standard error. And that's it right there. What's the probability that a sample mean will be less than 5.5? That's when we're going to use the norm dist again. Equals norm dist. There it is right there. First thing they want is the sample mean, and that's the 5.5 from the problem, comma. The mean is 5.3, comma. Standard deviation is 1.5 divided by 7.1, the one we just figured out ahead of time. It's going to be 2.11, but we'll let the software handle that. And it's going to be true because it's less than, right? We don't have to subtract from 1. We hit enter. So let me move this over here and make it so you guys can see it. Do my characteristics switch over. So there's the probability that the sample mean of 50 will be less than 5.5. Okay, so that's pretty large because the mean is 5.3. So it's going to be over 50%. So that looks good. This is a between problem. 5.0 and 5.5. What I'm going to do is simply cut and paste the formula. And because it's a betweener, I'm going to copy and paste. Subtract, paste. So the first number is always the big one, so that's 5.5. That's 5.5, 5.3. Oh, it's already preset. Isn't that interesting? And the next one, I'm just going to change the 5.5 to 5.0. That's the smaller number. And everything else is the same. Bam. Pretty easy. Last one, what's the probability that a mean will be greater than? So greater than. I'm going to go ahead and copy the formula. And it's a greater than. That means I got to go up between the equal sign and the n and put 1 minus. And then we got to do 6 feet. So that's going to be our random variable. So 6 feet. The mean is still the same. Standard deviation is still the same. Standard error, I'm sorry. Hit enter. So there's the probability. It's very rare that you're going to get a 50 sample size with a mean that's greater than 6 feet. But it's not impossible. It's just 5 times out of 10,000. All right, that's it. MGZ out.